Good day, students. Welcome and thank you for tuning in to listen to the radio lessons produced for the Namibia Senior Secondary Certificate Ordinary Level Geography Grade 10 to 11. Today we start with a series of lessons on river processes and landforms. It is important that you tune in for all 5 lessons to gain a clear understanding on this topic. Now, listen carefully to the lesson and remain tuned in to answer the questions at the end. Now, listen to the lesson. Pedal hard! We are almost past those rapids.
Careful, Anne. You're gonna make us tip over. You don't pedal hard enough.
That's easy for you to say. I'm trying my best to keep us steady.
That was hectic. Is everyone okay?
For me, it was more than hectic. I almost ended up in the water. Can we go on shore?
Yes, it is time for a break. Let's pedal to the riverbank.
Guys, it is so amazing to be out here on the river. I totally enjoy being on such rough water.
When a river flows roughly, as you put it, then it is described as turbulent flow.
Does this mean that the water flows in circular movements?
Yes, it is caused when the riverbed and banks are uneven and rocky. Friction is then created, and when the water must overcome this friction, it then flows in swirling currents over eddies.
But this is what makes it more fun. I can do this every day.
Well, you will do this every day for the next few days. I mean, just look at the river. It seems endless, and if it does not have a beginning nor an end.
Don't worry, Jill. We will reach the end, and the river indeed has a beginning and an end. It is called the source and the mouth of the river.
The source and the mouth. I think I know which is which. The source is where the river starts and the mouth is where it ends.
And the smaller streams and rivers that flow into the main river are called tributaries. What do we call the point where tributaries enter the main river?
I think that is called the confluence.
Good. But who can tell me what is meant with the river shed and the drainage basin?
To me, those words sound very strange.
I think the watershed is the higher lying land which forms the boundary of a river basin and separates 2 drainage basins.
That's a mouthful. Please repeat.
Okay, I will say it slowly. The watershed is the higher lying land which forms the boundary of a river basin and separates 2 drainage basins. So, is it the same thing when one talks about a river basin and a drainage basin?
Yes, it's the same. And what is the drainage basin?
I think the drainage basin is the area of land drained by a river and its tributaries.
Very good. Now, as a river flows downstream from its source to its mouth, its features also change from source to mouth. This flow from source to mouth is the long profile of a river, and it has 3 stages. 1, the upper course, then the middle course, and then the lower course.
But how do these features of the river change from the upper course to its lower course?
Okay. The steep and narrow valley sides become more gentle and wider in the middle and lower course. The gradient also changes from steep to more gentle from upper to lower course. But the river actually flows faster in the middle course than in the upper course.
But wait, sir, how can the river flow faster in the lower course where the gradient is gentler?
Thank you. You see, in the upper course, the channel is narrow with large angular bedrock which cause more friction but it becomes wider because the river erodes in different ways in the upper and lower course. In the upper course, the river erodes vertically, that is downwards, creating the steep valley sides, and in the middle and lower course, the river erodes laterally or sideways. This means more erosion along the banks, so it becomes wider.
Does it also become deeper?
Yes, as more tributaries add water to the main river, more erosion occurs on the bed and along the banks, so it becomes wider and deeper. And now that the river has a great volume of water and it is deeper, there is less friction to overcome and it flows faster, even though the gradient is gentler.
But the river also changes. Sir, before you continue, can I just make sure? Is the riverbed the bottom of the river and the banks of the river are the sides?
Yes, we are now standing on the banks of the river, which reminds me, we have to get back on the water again so that we can reach the campsite before dark.
Yes, okay, let's do this. I am ready for more turbulent waters.
Yes, hop in the canoe, Jill, but don't worry, the water is quieter further downstream. Remember, when water flows quietly or in layers parallel to the riverbed, it is described as laminar flow.
I'm so ready. It will be so nice to just row on calm waters. Then one can enjoy the beautiful landscape more.
Ha, I second that. Where's my life jacket?
Wow! How interesting to learn about the river features found along the course of a river. I can't wait for tomorrow's lesson to learn more. But now it's question time. Today's question is, what is meant with the term watershed? Is it A, the point where a tributary enters a main river? B, the area of land drained by a river and tributaries? Or C, the higher lying land which forms the boundary of a river basin and separates two drainage basins? That's the question. Now, thank you so much for listening. Tune in again tomorrow to follow the journey of the geography students.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Welcome and thank you for tuning in to listen to the radio lessons produced for NSSCO Geography Ordinary Level Grade 10 to 11. Today we will listen to the second lesson of our series River Processes and Landforms. It is important that you tune in for all 5 lessons to gain a clear understanding on the topic. Listen carefully to the lesson and remain tuned in to answer the question on your own at the end. The keyword for today's lesson is erosion. Now listen and remember the keyword is erosion. Well, how do you guys feel after the day on a river? canoeing and paddling your way through turbulent waters?
I am totally exhausted. I enjoyed it, but my muscles already feel stiff.
I'm looking forward to a good night's sleep. For me, it felt like the whole day of physical work.
Well, Kate, the river was also at work. In fact, it works non-stop.
What do you mean, sir? What kind of work does the river do?
The river works by eroding its bed and banks.
Oh, yes, sir. I remember. You said that when a river erodes downwards, the riverbed becomes deeper. I think that was called vertical erosion.
And when the river erodes sideways, the banks are eroded and the river becomes wider. This is called lateral erosion.
Good. Another type of erosion is headward erosion. This occurs at the source of the river where it cuts backwards into the mountain in the opposite direction that the river flows.
But how is that possible?
It can occur during heavy periods of rain when erosion occurs faster.
But how does the river carry out erosion?
Very good question. There are 4 ways in which erosion is carried out. These are hydraulic action, attrition, corrosion, and corrosion.
Wow, sir, can you please describe these processes?
Okay, no problem. Hydraulic action occurs when the sheer force of the river current causes water to enter cracks which occur in the bed and banks of the river. When air is compressed, it expands and forces the cracks to become bigger and pieces of rock break off.
And what happens to these pieces of rock?
Okay, they are carried by the river and bumped into each other and further break up into smaller pieces.
I think this is so cool. But is it possible that these small pieces also erode the river?
I think that's called corrosion. The materials carried by the river scour and scrape the bed and banks, wearing them away. This process is also called abrasion, isn't that right, sir? But you also mentioned corrosion. Now I'm a bit confused.
Yes, one can easily get confused with corrosion and corrosion. I think an easy way to remember them is to link the A in corrosion with abrasion, which occurs when the materials score and scrape against the bed and banks of the river, and link the O in corrosion with the O in dissolves, which occurs when acids in the water dissolve certain types of rock. But erosion is not the only work that the river performs. It also carries the eroded material. This is called transportation. And the material that the river carries is referred to as the load of a river.
So, sir, does it transport load with different sizes in different ways?
There are 4 ways in which the river transports its load. It's called traction, saltation, suspension, and solution.
Does solution have something to do with corrosion?
Yes, the materials that are dissolved are carried in solution. The second method of transport is suspension, which means that fine grains of sand that are light enough simply float in the water and are carried along.
So traction and saltation carry rocks?
Yes, you are partly right. Traction is when rocks and large boulders that are too heavy to be lifted by the water are pushed and rolled along the riverbed, while saltation happens when smaller pebbles bounce along the riverbed in a leapfrogging motion.
But sir, I don't understand why the river water is brown in color.
The load carried in suspension usually consists of fine particles of clay and silt, which give the water this brown color. But the river does not only erode and transport, At times, it also deposits its load. If transportation means that the river carries its load, then I guess that deposition means that the river puts down its load. When the river erodes and transports, it requires energy to do so. When a river no longer has the energy to carry its load, it will deposit it.
Sir, can you explain to me how does a river gain energy?
Alright, it gains energy when the volume of water increases and the river can overcome friction. But when the river loses energy due to increased friction, it cannot carry its load anymore and then the load is dropped.
So, do I understand correctly when I say it's easier for water to overcome friction where the channel is deeper?
Correct. Normally, the faster current flows where there is least friction, that is, far from the bed and banks. But where the water comes in contact with its bed and banks, more friction occurs. Friction causes the river to lose energy, so it will flow slower. As the river loses energy, it deposits the load it carries.
I almost lost all my energy today, so I can't carry myself anymore. And now I want to deposit myself into my sleeping bag. Oh.
Me too. I have carried this heavy load the whole day. I also want to deposit myself.
That's funny, sir. Yes, I agree. Let's retire for the night. But remember, no naughty tricks tonight. We all need a good night's rest because tomorrow will be a long day. Good night, everyone.
Good night, everyone.
Good night, sir.
I hope the group will sleep well tonight and that the girls don't play tricks on the teacher while he sleeps. But now it's time for the question. Today's question is: choose the correct term for the following transportation method in a river. The process during which smaller stones are bounced along the riverbed in a leapfrogging motion is A. Traction, B. Saltation, or C. Suspension. Let me repeat. The process during which smaller stones are bounced along the riverbed in a leapfrogging motion is A. Traction, B. Saltation, C. Suspension. That's the question. Thank you for listening. Tune in again tomorrow to follow the journey of the geography students. Thank you so much.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Good day, students. Welcome and thank you for tuning in to listen to the radio lessons produced for NSCO Geography Ordinary Level, Grade 10 to 11. Today, we will listen to the third lesson of our series, River Processes and Landforms. It is important that you tune in for all 5 lessons to gain a clear understanding on this topic. Listen carefully to the lesson and remain tuned in to answer the question afterwards. The key word for today's lesson is waterfall. Now listen to the lesson. Wake up! Wake up! It's a lovely day today.
Oh, I still want to sleep.
Last call to wake up. Breakfast is in 10 minutes and after that you have 10 minutes to be on the water.
Come on, you lazy head. We already took a swim in the river.
We're coming.
Right, good. Now that we are all here, Today we will continue further downstream and we will encounter some more rapids.
I'm so excited for the rapids.
Sometimes the rapids are very strong. The paddling really works hard on one's muscles.
You got that right. I hope I won't lose my energy when the river gains energy.
That makes two of us. Sir, the water is sometimes so fast in rapids that I wonder if it isn't a waterfall.
No, they are not the same. However, both are formed when the river flows over areas with bands of hard and soft rocks, otherwise known as resistant and less resistant rocks. Waterfalls are formed when the resistant rock lies horizontally or vertically, or if it slopes upstream.
No, so what do you mean with a rock is more resistant?
Remember that yesterday we talked about erosion.
Yes.
So, if a rock is more resistant, then it means it is not easily eroded. But while the more resistant rock remains intact, the softer layer of rock which lies beneath the more resistant rock is eroded away by the river. And erosion continues to wear away the softer rock. The more resistant rock is left unsupported, forming an overhang.
So, if the more resistant rock is left unsupported, will it collapse?
Yes, the overhang will eventually collapse and then the water drops down vertically.
Wow, waterfalls are spectacular. We visited the Victoria waterfalls during the last holidays. It's amazing to watch huge volumes of water just tumbling down vertically. Will we come across waterfalls along this river, sir?
No, unfortunately not. We are very far downstream. But let me finish my explanation. The fallen rocks then play a role at the bottom of the waterfall. These pieces of rock are swirled by the falling water. In the process, they score and scrape the bottom of the waterfall and create a plunge pool.
Scoring and scraping. That's abrasion. So the plunge pool is formed by abrasion. Does the plunge pool become wider and deeper through abrasion?
Yes, indeed. And as the plunge pool is widened and deepened, more of the softer rock is further removed. And then...
Oh, I know. It leaves the hard resistant rock unsupported again, causing it to collapse.
Collapse! And as it collapses, the fallen rock continues to widen and deepen the plunge pool. So this process is repeated over and over. Is that right?
Indeed! The continuous collapse of resistant rock and the widening and deepening of the plunge pool cause the water to retreat backwards.
Retreat backwards? What on earth does that mean, sir?
Okay, it is actually similar to when you take a step backwards. The waterfall also moves backwards very slowly over a long period of time and leaves behind a steep-sided gorge.
A gorge?
Yes, a valley with very steep, almost vertical sides.
And so how are the rapids formed?
For rapids to form, the more resistant rock slopes downstream. This means that it allows water to speed up and then it flows faster over the more resistant rock. Rapids increase the turbulence of a river and also its power to erode.
That's so interesting, sir. But apart from waterfalls and rapids, what other landforms are created in the upper course of a river?
Well, other landforms along the upper course include V-shaped valleys and interlocking spurs as well as potholes. Remember that we said yesterday that the valley sides are much steeper in the upper course than in the lower course.
Yes.
Now, the steep valley sides are formed when the river transports material along its bed. This material cuts downwards into the bed of the river. What is this type of erosion called?
I know, it's called vertical erosion.
You are right. Now, vertical erosion and erosion caused by heavy rain work together to form a V-shaped valley. The steep valley sides are formed because it erodes faster downwards, then it becomes wider. As we can see, rivers do not flow in a straight line. They turn and bend around mountains. Eventually, pieces of land called spurs interlock with the valley sides.
And what about potholes?
Okay. These are formed when rocks on the riverbed are trapped in hollows on the floor of the river. Fast-flowing water then swirls the rock around. In the process, the rock scorch against the riverbed, carving out a pothole.
So these potholes create an uneven riverbed, sir?
Yes, it does. This is typical along the upper course. An uneven bed further contributes to turbulent flow. Okay, enough learning for today. Let's get the canoes in the water.
Sir, yes, sir.
Right, well, what a lot of information. Waterfalls, rapids, V-shaped valleys, interlocking spurs and potholes. Students, please ensure that you do revise these sections. But now, it's question time. Today's question is, choose the correct term for the following description. The pool created at the foot of the waterfall by the fallen rocks is called A whirlpool, B, a mud pool, or C, a plunge pool. Let me repeat. The pool created at the foot of the waterfall by the fallen rocks is called A whirlpool, B, a mud pool, or C, a plunge pool. Thank you for listening. Tune in again tomorrow to follow the journey of the geography students.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Good day, students. Welcome and thank you for tuning in to listen to the radio lessons produced for NSSCO Geography Ordinary Level, Grade 10 to 11. Today, we will listen to the fourth lesson of our series, River Processes and Landforms. It is important that you tune in for all 5 lessons to gain a clear understanding on this topic. At the end of this radio lesson, you should be able to answer the question provided at the end. Now listen to the lesson. Yoo! What a beautiful scenery. Green surroundings, quiet waters, so peaceful. It's fantastic.
Fantastic indeed, sir. I completely agree. It's beautiful out here.
Just look at how wide the river has become, and the valley sides are so gentle. There's a huge bend in the river ahead of us.
Okay, well, you guys are really observant. I am impressed. Jill, here is a map that shows the river. You will see that there are many bends along the course of the river. These bends are called meanders. They develop as the river flows over gentler land.
Sir, why is the one bank of a meander steeper and the other one is gentler?
The steeper side develops on the outer bend of the river and the gentle side develops on the inner band of the meander. As the river flows around the bend, the faster current is channeled towards the outer band. The faster current erodes the outer band, making it wider and deeper. This undercutting creates a steep side, which is called the river cliff.
Does the opposite then happen on the inner bend?
Oh, what do you think?
Let me try. I think that the opposite happens on the inner bend. The slower current is channeled to the inner bend. You told us previously that as the speed of the river decreases, it loses energy and it deposits its load. So with the slower current on the inner bend, the river deposits its load on the inner bend. The deposited material forms a gentle side.
You are correct. The slower current takes the inner band and deposits material. The deposited material develops a gentle riverside called a slip-off slope. The slip-off slope increases friction, which slows down the current on the inner band even more, causing more deposition to take place.
But sir, can erosion also increase on the outer bend?
Yes, as undercutting continues on the outer band, the river also develops in a small overhang which is unsupported and will eventually collapse.
So does the river become wider where the river cliff collapses?
No, not really, because while erosion undercuts the outer bank, the inner bank is built up by deposition. Instead of growing wider, the river is rather caused to migrate sideways.
I never knew that rivers can also migrate. Isn't it only people and animals that migrate?
Well, rivers do migrate. This accumulation of deposited material on the inner band and simultaneous erosion of the outer band cause the river to shift sideways.
That's interesting.
More interesting could be the fact that the meander could become completely isolated from the river.
Isolated from the river? Do you mean completely cut off from the river?
Yes, because constant erosion on the outer band of a meander causes the neck of the meander to become narrower.
So what is the neck of a meander, sir?
This is the piece of land within the meander. As erosion on the outer band continues, the neck becomes narrower. In time, especially during a flood, the river will cut right through the neck. This happens because the river flows too fast to go around the bend and now just takes a shorter, straight route through the narrow neck. Because the river now flows in a straight path, the faster current is now in the center of the river and the slower current tends to be along the banks.
So, sir, does the friction with the banks slow the current along the banks?
Yes, indeed it does. And what happened as the current slows down?
Deposition? So now deposition occurs along the banks.
Yes, and eventually deposition will block off the old meander and leave behind an Oxbow Lake.
Is it called an Oxbow Lake because of its shape that's similar to the hoof of an ox?
Correct. The Oxbow Lake is cut off from the river and it may dry up. If all waters dry up completely, the Oxbow Lake leaves a scar behind. This is called a meander scar.
Oh, now I see. Are there any more landforms along the course of a river?
Yes, there are. Just look around you. What is the land like next to the river? Very flat and gentle. The flat land over which a river meanders is called floodplains. It can also be described as the flat areas next to the river, which is flooded when the river overflows its banks.
So those marks over there show us up to where the water traveled when the river was in flood?
Yes, when a river bursts its banks, any surrounding flat land will be covered with water. When the river is in flood, it enters shallower land, which means more friction occurs.
And I think friction slows down a river. So this means that the river loses energy and materials are deposited.
Yes, fine material carried in suspension will be deposited and covers the floodplain with a thin layer of silt, which creates very fertile soil.
So there are some advantages when a river floods. It brings fertile soil which can be used for agriculture and also water to irrigate the crops.
Small river banks can also be formed by deposited material. Coarser material is deposited first because it is heavier. After continuous flooding, the coarser material accumulates on the floodplain, forming small embankments. These embankments are called levees.
So is material only deposited on the banks and the floodplain of a river?
No, material or silt can also be deposited on the riverbed when the river is not in flood. Constant deposition will cause the riverbed to grow higher. This means that the river can eventually flow above its floodplain if the riverbed becomes raised higher.
But sir, I've seen rivers where deposition occurred in the middle of the river. How is that possible?
Deposition can occur in the middle of a river during the dry season when the river levels fall. Material is deposited and then builds up into small sand islands in the middle of the river. These are called eyots. The main streams then breaks up and flows around these eyots. This process is called river braiding.
Sir, we have now learned that in a meander, the faster current takes out the outer bend, undercuts the bank and creates a river cliff. The slower current takes the inner bend, deposits material which builds up into a slip-off slope.
And we also learned that meanders can migrate and further erosion on the outer bend narrows the neck and eventually an Oxbow Lake develops.
Also, that the deposition occurs on the floodplain when the river is in flood. Coarser materials are deposited first as it accumulates on the river banks. Levees can develop.
Finer silt is deposited further up the floodplain, which forms fertile soils.
But when the river does not flood, silt is deposited into the riverbed. As silt accumulates, the riverbed is raised higher. This means that the river could flow above its floodplain. And during dry seasons, the river levels may drop, and as water becomes shallower, silt is deposited as sandbanks or eyots. The river breaks up to flow around these eyots. This is called river braiding.
Yes, and I have taught you well. No further landforms for today. Only rowing for the rest of the day so that we can reach the second base camp by lunchtime.
Best idea for the day. So guys, let's work together because lunch is waiting.
Yippee!
While the group is on their way, I have another question for you. Today's question is: the faster current in a meander flows along the A. middle of the channel, B. the outer band, or C. the inner band. Let me repeat the question. Today's question: the faster current in a meander flows along the A. middle of the channel, B. the outer band, or C. the inner band. Thank you very much for listening. Tune in again tomorrow to listen to the last lesson in our series of river processes and landforms.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.
Good day, students. Welcome and thank you for tuning in to listen to the radio lessons produced for NSSCO Geography Ordinary Level, Grade 10 to 11. Today, we will listen to the last lesson of our series, River Processes and Landforms. Listen carefully to the lesson to answer the question at the end. Hi, students! Are you ready for our last day on the river?
Yes, sir.
Oh, but we're not ready to go home yet. It's so much fun to be here.
Yes, I know. But we must still discuss 2 more landforms in the lower course of the river. Then we can spend the afternoon swimming in the river and playing volleyball on the riverbank. I promise you that it will be great fun.
I'm looking forward to show the boys that us girls are undefeated volleyball champions.
Bring it on. What are the last 2 landforms that we should know about, sir?
Okay, these are deltas and oceanas.
Deltas, like the Okavango Delta and Oceanas, the flat, sandy plains that are filled with water during the rainy season in northern Namibia.
Indeed, deltas can develop in inland low-lying areas, but also at the coast. However, their formation is similar.
So how are deltas formed?
In the lower course, rivers contain large amounts of material that can transport to their mouths. If a river flows into a relatively calm sea or lake, then its speed will be reduced and...
Oh, the material will be deposited. Now it's so much easier for me to remember. Where a river's speed is reduced, it loses energy and it then deposits material. The deposited material increases friction and so further reduces the speed of a river. And I think, sir, the opposite is also true. So where a river flows fast or its speed increases, it gains energy and has the ability to erode more.
Very good. Faster flow usually causes erosion and slower flow usually leads to deposition. Now, for deltas to form, deposition takes place and no erosion occurs. This means that as the river slows down, fine material is deposited. Where the ocean is shallow and where the ocean currents are not strong enough to remove the deposited material, it will build upwards and outwards, forming a delta.
Wait a minute, but won't this accumulated material now block the way of the river on its way to the ocean or lake?
Yes, in fact it does. In order for the river to reach its mouth, it will now break up into many small streams to reach the ocean. These many small streams are called tributaries.
Tributaries? Are they not called tributaries?
No, they are called tributaries. Who can explain the difference between tributaries and tributaries?
I think I can. Tributaries are the many small streams into which a river must break up to reach the ocean if there are large amounts of deposited material in its way.
And if I remember correctly from our first lesson, tributaries are the small streams that enter a river. Sir, what happens when the fresh water from the river now meet the salty seawater?
When the fresh water meets the salty seawater, an electric charge is produced. This causes clay particles to coagulate and to settle on the seabed. This process is called flocculation.
What does it mean when the clay particles coagulate?
When clay particles coagulate, it means that they stick onto each other. After this, they settle on the seabed.
So does this mean that deposition is further encouraged by flocculation?
Yes, indeed. Now let's revise the process of flocculation again. At the mouth, fresh river water meets salty sea water. an electric charge is produced. This causes clay particles in the water to stick onto each other and settle down on the seabed. So more deposition and accumulation of clay and silt occur.
So now the river breaks up into smaller channels to reach the sea.
Yes, and so deltas are formed. The deposited silt provides very fertile soil for agriculture. However, deltas could also bring problems. Now, these are the problems that are caused by deltas. Number 1, they are flood risk areas. Number 2, boats can get stuck in the deposited material, so it hinders their navigation. Number 3, due to the large amounts of deposition, the channels change often and it can also pose a problem for navigation.
Sir, you mentioned that deltas could be formed at an ocean or also an inland. But what about oceanas?
Well, oceanas are formed inland, in particular in northern Namibia, when long, flat, open, sandy plains are filled with water during the rainy season. Have you heard about the term efunja?
Yes, sir. My grandparents in the village is in the Oshana region. The flood waters come down from the Angola and people call it Ifunja.
Yes, the water flows into the oceanas in a process called efunja. What else can you tell us about oceanas?
The people are very grateful when the Oshanas are filled with water. They plant mahango seeds before the floods and then they use the water to irrigate the crops. People also catch fish and collect water for cooking and drinking. But we often hear about people's crops being destroyed by these waters. Sometimes huge amounts of water reach the Oshanas and cause floods. Then homesteads and croplands are totally underwater. Then people lose their source of food. Sometimes villages are completely surrounded by water and completely cut off from the outside world. Sometimes people also drown in these waters.
Just imagine being surrounded by water for weeks.
Yeah, no. The stagnant water also attracts mosquitoes, so malaria and other waterborne diseases could also spread. People could also be left without any clean water for cooking and drinking. They often have to abandon their homes for weeks while waiting for the water to drain away.
There are so many problems created by floodwaters, but people still choose to live on the floodplains and other areas such as the Oshanas, which could also be flooded. I don't understand why.
Well, floodplains do provide fertile soil to plant crops, to eat, and also to sell for an income. I read that people in China use their delta areas to grow rice.
I think people can also build settlements much easier because these areas are very gentle. And the rivers could also provide fish for people to eat and sell for an income. I see that there are many advantages to living close to rivers or on floodplains. But there's one more benefit which we should not forget about. I think that's swimming in the river and playing volleyball.
Most definitely. Rivers can also be used for recreation and sports. So which team will win the volleyball?
The undefeated ones, of course.
Woo! Wow! Such fun to take a splash in the river now that all work is done. Yes, this was our last lesson in the series River Processes and Landforms. Now for today's question. Sometimes a river has to split up into a series of smaller channels to enter the ocean. What are these smaller channels called? Choose between A, B or C. A, is it called tributaries? B, distributaries. C, arteries. I will repeat. Sometimes a river has to split up into a series of smaller channels to enter the ocean. What are these smaller channels called? Choose between A, B, or C. A. Tributaries. B. Tributaries. C. Arteries. Thank you for listening to the last lesson in the series, River Processes and Landforms. Remain dedicated to your studies so that you may achieve success.
This program was brought to you by NAMCOL with funding from the Ministry of Education, Arts and Culture and the Commonwealth of Learning.